What if I told you one simple change in a number could update your entire model instantly? Welcome to the world of equations in SolidWorks, smart, efficient, and fully parametric. In today's video, we are diving into the power of parametric modeling using equations in SolidWorks. Whether you are designing the complex part or everyday components, equations can help you to automate your workflow, reduce errors, and save hours of rework. Equations in SolidWorks let you to link the dimension, features, and parameters using mathematical relationships. Imagine saying if I change the number of teeth, it automatically adjusts the pitch diameter, helix angle, and the tooth width. That's what the equation do. Now, let's understand what are the equations in SolidWorks and how to use them to automate your workflow. I will show you exactly how it works by creating the helical gear, all driven by equations. Now, the first question is, where is equation? If it is not available in interface by default, then you can go to the command search and type equation. You can activate it by clicking, or if you want to be it in tool panel, then just drag and drop it. Once you have activated the equations, the dialog box appears, having various options to automate your modeling process: global variable, features, and equations. Now, let's briefly understand what are these options. Global variables in SolidWorks are the named values that you define once and can reuse throughout your model to drive dimension, features, and other calculations. For example, if the number of teeth is 30 and the module is 1 mm, we know that the pitch diameter for the gear is module times the number of teeth. So instead of typing pitch diameter equals 30 times 1, we can define the module values and the number of teeth values and the other necessary parameters, and then we can use them throughout the modeling process. Once you define the global variables, then click on the OK button. The equation dialog box closes, create a circle, and then apply the dimension. Now activate the equations option. We have defined the global variables, and now let's move to the equation section. The equation section is where you define the mathematical relationship between the different dimensions, global variables, or feature parameters. These equations control your model by linking one dimension or parameter to another using mathematical relationship. Like we created circle to define the pitch diameter of the gear. So click on the add equation box and then select the default dimension applied to the circle. The sketch gets selected, and now we can define the relation for pitch diameter in value equation section, that is module times number of teeth. Then click on the green tick. The value updates automatically, that is 30 mm. Now, when you change the teeth or module, let's say we change the module to 1.5 mm, the sketch dimension will be updated automatically like this. And this way you can automate your most of the workflow. Moving on to the feature section. In feature section, you are able to drive the feature parameters using equation or global variables. This allows you to suppress or unsuppress the feature based on the other dimension or relations. Let's say we want to suppress the extruded cut in the gear in several conditions, like when the outer diameter is more than 30 mm, then suppress the cut. To do so, click on the Add Feature Suppression option. Then select the extruded cut feature. Now from the function option, apply the if condition and then select the outer diameter of gear. After that, enter more than 30, comma, suppress, then again comma and unsuppress, and click on the green tick. Now let's say we change the module to 1.2 mm. Then the outer diameter is increased and the cut is suppressed like this. This way, you can suppress the multiple features according to your requirement. Now, in next part, we will be creating the helical gear, all driven by equation. So stay tuned for next part.